So here we have 5.5a, which is solving quadratic equations by factoring. Okay, and our objective with this is to solve quadratic equations by factoring. So really, the whole point of this, so the reason why we have been factoring for the past couple of days, and you've had various situations, special instances of like differences of squares or perfect square trinomials, or if you have four-term polynomials or just the regular trinomials. The whole reason why we had to learn to factor is to actually be able to solve. So solving these equations is actually the crucial part. So basically we did all the prep work so that way this next step will be a lot easier, and now you'll understand why we've been doing this and why it's been important. Okay, one big thing. Whenever you're solving by factoring too, just so you know, so all these solving by factoring, you can have a quadratic and linear term, or you could have a quadratic, linear, and constant term, or you can have like we did in the last section where you had a four-termed polynomial. All of those types of things you're going to do by factoring. But the big thing is you're going to have a linear term if you're going to solve by factoring. We'll see a different way of solving in the next lesson when you wouldn't have a linear term and what you can do. So you're going to basically see a lot of trinomials, to be completely honest with this. Okay? The big thing is all equations must be set equal to 0. Okay, so all equations must be set equal to 0. The reason why is when we solve quadratic equations, we're actually finding the x-intercepts of your parabola graph. Remember when we were graphing parabolas? And you had to find your vertex and, one of the points and then another point and all of that stuff, your left coordinate, your right coordinate, all of those things. Well, one thing that we did not do with the parabola was actually find the x-intercepts. So we are actually going to do that algebraically here, and I'm going to give you a visual of the graph. You don't necessarily have to graph them, but I'm just going to try to show you that visual. Okay, so let's look at our first problem. Our first problem is x squared minus 11x plus 19, and that equals -5. So again, everything has to equal 0, because what you have to remember with your quadratic functions, remember it's y equals ax squared plus bx plus c. Okay, that was a gross c. And so like my y has to be 0 in order to find out my x-intercept. So that's the whole point with solving. So again, the whole point with solving is to be able to find out what the x-intercepts are for your parabola graph. Okay? And so I'm first going to add 5 to both sides. So then I get x squared minus 11x, and then that is going to be plus 24 equals 0. So now I'm good. Okay, now I can go about factoring. You can do your X method, you can do your trial and error, however you want to do it, okay? And so we can do -8 and -3. Now because A is 1, that's always the best because I can use my shortcut. So I have x minus 8 times x minus 3, and that equals 0. So this is the big transition with this section here, because we're used to just having expressions. Now at this point, after I factor, I have to do something with it. So like before, factoring was the answer, whatever I factored. Now that's just a step in the process, okay? And so now what I'm going to do is I'm going to set each binomial equal to 0. So I get x minus 8 equals 0, and I get, x minus 3 equals 0. Okay? So now I need to add 8 to this side, to both sides, I should say, and add 3 to both sides. So then my final answer, I'm going to get x equals 8, and I'm going to get x equals 3. Okay? So then that is my final answer. I have solved this quadratic equation by factoring. So you factor, which we have been doing. You set each binomial equal to 0 and solve. So what that means is these are my x-intercepts of the quadratic function. So again, for this problem, we got x equals 3 and x equals 8. And so what that means is 1, 2, 3, 4, 5, 6, 7, 8. So what that means is this parabola, oh, that was a little bit gross. Just pretend that it goes actually through that. This parabola is going to go through the points 3, 0, and 8, 0, because what I did was I found the I found the x-intercepts, okay? So the reason why you have to set it to equal to 0 is because you're finding the x-intercepts, okay? So whenever you're asked to solve a quadratic equation, you're basically finding the x-intercepts of the graph, okay? So you could be asked, solve the quadratic equation, okay? You set it equal to 0, you solve, those are the x-intercepts. Or I could say, determine the x-intercepts of this function. And then that, that should trigger, if I need to find the x-intercepts, that means I basically need to solve by factoring, okay? So kind of keep that in mind, especially on the college level, like the LSU class that I teach. They'll say, what are the real zeros of this graph? Or what are the x-intercepts of this graph? They're not going to ask you to solve the equation by factoring. They're actually just going to downright ask you for the x-intercepts, and you have to know that you're solving by factoring. So kind of keep that in mind. Let's look at another problem. I have number 2 here. So I have 6n squared minus 18n minus 18 equals 6. Remember, you have to set it equal to 0 because your y value has to be 0. So I'm going to have 6n squared minus 18n minus 24, and that equals 0 because I added 6 to both sides. I subtracted 6, not added 6. Oh, Lord have mercy. I subtract 6 to both sides because 6 is positive there. So then, if you notice, I do have a GCF of 6. I can factor out a 6 out of all of this because 6 is in common. Okay, that is incredibly helpful. You'll notice it's super helpful if you have a GCF. Now, I'm going to factor, I have -3, -4, so I'm going to have -4 and +1. My A value is 1. If you notice, I'm going to go pretty quickly through factoring. We've spent a lot of time on it. This 6, remember, stays along for the ride, and then I get n minus 4 times n plus 1, and that equals 0. So now, the thing is, before, in the last problem, I said set each binomial equal to 0 and solve. In this case, because I factored out a GCF, I have to take each component, okay? But notice, you have to ask yourself, does my GCF, out of the whole thing, does it have a variable with it? If the answer is no, which in this case it is no, 6 does not have a variable with it, I actually don't need it, okay? I do need it to like factor out or to, say what's the simplified version or blah, 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 okay? But I don't really need the 6 to solve this equation because there's no variable with it, okay? But I am going to set n minus 4 equal to 0 and n plus 1 equal to 0. Now, truly, do you have to show this step? No, you don't. You can probably do it mentally, and that's a good thing. Okay, so I'm going to get n equals 4, and it equals -1. And typically, like what I will say on the collegiate level, if you ever take a college course, typically they want you to write your answers separated by a comma. That's at least what the LSU course that I teach asks how their answers are written. Okay, so what this means is that the x-intercepts on this graph are at 4 and -1. So I've got 4, I've got -1. That's where, oh, that's a little bit gross, but that's where my x-intercepts are going to hit. Okay, so just so you know, that is the whole point of what we're doing. The whole point of what we're doing is to actually figure out where is the parabola hitting the x-axis. Okay, I do have 2 more problems that I do want to look at. They're a little bit different than 1 and 2, so that'll be on the next video.